everyone, it's Alyssa and welcome to You Can Learn Math. Today is about long division, but not just long division with remainders, which was in a previous video, link down below, but it is long division with decimals. So what does this mean when we're doing this? Okay, so here is a sort of standard long division. Let's say if I had 4 into 102, right? Our process, we say, does 4 go into 1? No. Does 4 go into 10? Yes, it goes into 10 2 times. Then I multiply back. 2 times 4 is 8. Then I subtract. 10 minus 8 is 2. Does 4 go into 2? No. So I bring down, come on, I bring down that 2. Does 4 go into 22? Yes. 5 times. I'll change my color. So then we say, okay, 5 times 4 is, why is it not letting me do that, is 20. Okay, then we would subtract. 22 minus 20 is 2, so we have a remainder of 2. Okay, so far so good. Well, what if we don't want to have a remainder? They're going to get to this point where remainders are no longer really allowed. They aren't done. So how do we do it without a remainder? Well, let's back up to this point and say, okay, I've got a 2. Well, if I can't have a remainder, what else can I do? Well, before we answer that, let's look at when we're talking about decimals. If I say 2, or I'm just going to pick actually a different number, one that's unrelated to what we're doing so it's clear, right? A 7, and then 7.0, then 7.00, and 7.000. Are those different numbers? No, they're all the same. Same thing. Just like if I said I have $7 or I have $7. I'm writing that either way, it's exactly the same. It's 7 and nothing. So 7 and no tenths, 7 and no hundredths, 7 and no thousandths. So what we've learned here is that I can add zeros until my hand gets tired, and I'm not changing anything. Okay? Of course, that is after the decimal. I can keep adding those zeros and nothing changes. So what that means for our division is I can put my little decimal and add a 0 there. And that's the same, 102 and 102.0. I haven't changed that number, same number. Well, now I have another number I can bring down. I can bring down that 0. 4 goes into 20 5 times. 5 times 4 is 20. I subtract and I get 0. So I'm done. But one little thing, anytime there is a decimal, when we are dividing, that decimal has to be put straight above it. Okay? Has to. So there's my answer, 25.5. You go, 0.5, but we said it was a remainder of 2. How does that work? How is 0.5 the same as a remainder of 2? Well, here's the thing. The remainder of 2, we can also say that that is 2 over, another way of writing it, 2 over the divisor. So 2 over 4 is the remainder. Okay? Since that's also a fraction, we can reduce that. 2 over 4 can be reduced or simplified to 1/2. Well, what does this mean? This 0.5. 0.5. Everything after the decimal, we have a tenths place, a hundredths place, and a thousandths place, and so on. Just like if we're going this way, we have ones, tens, hundreds. So this is the same as 5/10. And we can simplify that to 1/2. So they are saying the same thing. Remainder of 2, or 2/4, is the same as 1/2, and 0.5 is the same as 1/2. Okay, let's try another one of these. Let's say I had something like 3 and 2, 101. Okay, 3 goes into 1? No, it doesn't. Does 3 go into 10? Yes, it goes 3 times. 3 times 3, I write that down, 9. Then I subtract, I get 1. Does 3 go into 1? No, so I have to bring down my next number, 1. Does 3 go into 11? Yes, it does. It goes 3 times. Then I'm going to change the color. Okay, then I'm going to multiply back. 3 times 3 is 9. Zoom out a little bit. 11 minus 9 is 2. Okay, does 3 go into 2? No, it doesn't. So I'm going to add my 0.0. That decimal is super important. Remember, I also want to put it above it. It has to be there, both places. So 33 point. All right, so now I've got this 0 that I can bring down. Does 3 go into 20? Yes, it does. 6 times. 6 times 3. It's a little bit too far. There we go. Okay, so 6 times 3. We just keep doing the same circle around. 6 times 3 is 18. 20 minus 18 is 2. Oh, wait, look here. We had a 2, and now we have a 2 again. What happens if we do this process again? Because I can keep adding zeros. I add a 0, I bring it down. Well, we're going to have the same thing happen again. 20 and 20. Okay, does 3 go into 20? Yes, 6 times. 6 times 3 is 18. I subtract, I get 2. This is going to repeat forever. This is never going to change. When this happens, when you know I'm just going to keep getting like this forever, depending on what your teacher wants you to do and what the problem asks you to do, sometimes it will ask you to round it like that. More commonly, it will ask you to do this. Put a line over the 6. That means that 6 repeats. It never ends forever. Now, that repeating thing can be extended. Let's say you have something that's, I don't know, you get where it's 1, 2, 1, 2, 1, 2 forever. You can write that with a line over both the 1 and 2 to indicate they both repeat. All right, one more, and I'm going to do it without the arrows and just see if you can follow along. So let's say if it is 5 into, we'll say 233. Right, does 5 go into 2? No. Does 5 go into 23? Yes. Goes 4 times. 5 times 4 is 20. I subtract 20 from 23, I get 3. Bring down my next number, a 3. Does 5 go into 33? Yes, it goes 6 times. 6 times 5 is 30. I subtract 30 from 33, I get 3. I don't want to have a remainder, so I'm going to add a decimal. And as soon as I do that, I need to put one right above it as well. Add that 0. Haven't changed anything. 0.0, it's still the same number. Now I can bring that 0 down. Does 5 go into 30? Yes, it does. It goes 6 times. 6 times 5 is 30. I subtract that, I get 0. This is the magic key. You're going to keep doing this. You're going to keep dividing and keep adding zeros until going to be a couple different things that can happen. You're going to get a 0, which means you are done. And you're like, okay, you're done. Stop. Don't do any more. And then you've reached your answer. Or you'll see a pattern like we did before where it was like 20 minus 18 is 2. 20 minus 18 is 2. And you start seeing that pattern repeating. Or if you don't see any pattern at all and it starts and it just goes with a whole crazy string of numbers. I can't think of any right off the bat as far as long division where that happens. Even odd things like 1 divided by 7, where you're doing 7 into 1 and you do like the 0.0 and add. Even that starts to repeat. It doesn't look like it's going to repeat. But the vast majority of them are either going to be, you never want to say never in math, but the vast majority are either going to end, you're going to get a 0, or you're going to start seeing a pattern where it repeats, where you get the same number going forever. Okay, so that is an overview of long division with decimals. These same principles will work if you are doing, if you're doing something bigger, like say a 2-digit number into a 4-digit number, any combination, it doesn't matter. Same process you do as if you're wanting a long division review. Again, the links would be in the description below. But the same sort of process, when you go through this and you do all your multiplication and you get to the point where you have what would normally be a remainder, same thing. You can add a decimal point, add a 0, put the decimal above it, keep going. And keep adding zeros until you reach a definitive endpoint or until you notice it starts repeating. So same principle, no matter what size the numbers that are dividing or being divided. Okay, and that's it for long division with decimal points. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.